Okay, so we'll start with the session. So we'll be covering the Ansys Discovery, its capabilities, and a live demo. How Discovery can help you out in various stages of for the simulation in your day-to-day work. So basically, Ansys is one of the first engineering simulation software leading in the market in the industry, with only focus on the simulation and not on the other physics. The pure focus is on the simulation side. So here are a few of the customers who are leveraging our platform, the Ansys Discovery and the various other tools like Fluent, Maxwell, Mechanical. So starting from the aerospace and defense through FMCGs, automotive, electrical, glass industries, and pharmaceuticals in the various domains, Ansys presence is there. So these are just a few of the list of the customers who are using Ansys in their day-to-day R&D work. So now coming towards the product portfolio. So based upon different physics, Ansys has developed each of the modules, starting from the materials for embedded softwares, safety analysis, for structural kind of simulation structures is there, fluids, that is basically the CFD module is there, then electronics physics is there, semiconductors. Likewise, our today's focus is the discovery part, which is included in the 3D design module. At the bottom, you can see the discovery module is there. So we'll be focusing on the discovery, basically what discovery is, how discovery can be utilized for the day-to-day R&D work, or the from the initial or the conceptual level of stage, how discovery can be utilized, and what are the ways and how you can implement it in your work. So basically, this is Ansys Discovery, which helps you for the more innovations, product increase productivity, quality assurance, how it helps with the innovations. So basically, if you go with any of the simulations, right, that will take a bit of more time. So when it comes to discovery, you can do the simulation quickly, very fast. Also, you can do the live changes, the live geometrical changes inside your simulation while the simulation is running. So when we talk about the productivity, so it helps us to reduce the engineering labor cost, also which also tends to decrease the physical prototypings. So once your physical prototyping is reduced, the productivity increase, and same goes with the quality. So if prototype typing is reduced, the testing and all the cost also reduced. So this how the discovery will help you in your day-to-day R&D work. So basically, when we talk about any of the simulations, so what is there? The skill, higher the skill, more the time. So basically, what discovery will help you out is somewhere in between the proficiency. So basically, for any simulation, there is a need of a simulation expert who has a particular knowledge in the simulation, the very from the beginning, or he is an developed skills in the simulation side. So how discovery will help you out here is, so while this slide you can see there are particular on the left hand side there are number of engineers and then there are simulation experts. So simulation experts basically are the experts who can utilize and have deep knowledge of the physics and the its knowledge, and basically the simulation experts work on the um, detailed simulations. So that generally takes a bit of more time as compared to discovery. So how discovery helps is, let's say you are having 10 or 15 designs, you want to quickly see at a conceptual or preliminary stage, if I change the diameter of the pipe, if I increase, then how the flow will behave, how the structural will respond, whether there will be flow separation or there will be turbulence created inside the flow, whether there will be reverse flow. So for this, you can utilize discovery. So discovery can be utilized by each and every engineer having basic knowledge. So there you can see, and then you can narrow down the results, and then simulation expert can work on that particular simulation in depth. So basic level of simulations can be done by the engineers using the discovery tool. So now the thing is, these are the various stages where simulations can be done. So majorly, the detailed simulation is the current scenario where we go for the detailed simulation, whether it's a mechanical, whether it's CFD, whether it's electronic. But discovery can be used at much below level, that is your conceptual and the preliminary level. So in these levels, you can utilize the discovery. So basically, when you use the initial level of simulation, so that helps you to reduce the cost, change of cost and knowledge. So at the very basic step, you come to know like these are the changes which we need to make for the further development. So that will also reduce your prototyping, your cost, and everything related to it. So now coming towards the main differentiators what Discovery offers compared to the other tools. So basically, it's pure simulation, just work. So when we do any kind of simulation, basically we have to uh, eliminate the overlappings. We have to fix the gaps and mismatches. We have to deal with the complexity of the geometry. So when we do with the discovery simulation, no defeaturing is required, no cleanup is required, no meshing is required at the initial stage. And these are the major benefits is less training is required, the faster time to do the simulation, and you get the flexibility to change and play around with the existing geometry. The other differentiators of the discovery is just the first one is the simulation. You can do the geometrical changes during the simulation. In between the simulation, you can change your geometrical changes, and your simulation will continue to simulate. Then you can do the multi-physics simulation. The user experience is very easy, and you can also connect this entire basic simulation to the Ansys portfolio for the in-depth simulation. And the third key differentiator is you have the multi-physics bundle in it. So basically, you can do the structural simulation, you can do the thermal simulation, you can do the electromagnetic simulation, you can do the fluid simulation, and then there is an option for topology optimization. So now my colleague will help you out with how to perform the discovery simulation using the structural part. Over to you, Anilji.
Yeah, hi Swam, thank you. Hi, good afternoon, everyone. So I am Anil Kumar, and I'm working at ARK as a structural application engineer. So today I will take you through regarding this ANSYS discovery capabilities and how it works. So basically, as Subham already explained very well about discovery capabilities, that discovery is a tool where even the designers at very basic level they can use and they can utilize this tool to optimize or to choose their one of the best design basically. So what happens at any organization as a CAE engineer, there are the ratio between design to CAE engineers is very large, we can say. So for 10 or 15 designers, there would be hardly one CAE engineer. So each and every design we cannot pass to the CAE engineer actually, because it would be very time consuming. And of course, so the concept is that at design phase itself, the designer himself can check and utilize this tool. This tool is very accurate. We can find out the best of the designs what we have. So for example, a designer have multiple ideas, so he can utilize this tool to find out which one would be the best fit, and then he can perform the analysis. He can apply the boundary conditions, he can check the strength, he can check the reaction forces, everything he can do at so basically it is messless. So easy to adopt, and learning is very user interface is very easy with this discovery tool. So and beauty of this tool is that even whatever work a designer has performed on that, he can surpass the same to the CAE engineer for expert or advanced level simulation basically. So the output we can export this file, which further can be utilized in advanced tools like ANSYS Mechanical or Fluent or some other physics related tools. So uh, now I will just share my screen and I will try to explain through basic just okay. So just I'm sharing my screen. So I believe my screen is visible. All right. So
Yeah.
you can see this is the user how interface it is. This discovery tool is very easy, we can say. And for example, there are different modes. This is the model mode. So there we can create our design from the basic scratch. We can create the sketch, and then we can create the surfaces, and then we can create the uh, 3D complex 3D CAD model also. So modeling is feasible. Then we have further explore and refine modes. There we can perform the simulation. So basically, there are different versions like Ansys Discovery Pro, Premium, and Enterprise. In Enterprise, it supports for Ansys Mechanical, Ansys Fluent, and similarly we have the capability for EMI also, so electronics as well. So in structural, if you talk about structural capabilities, so using Ansys Discovery, we can perform static structural analysis. We can find out the model natural frequencies up to 12 mode shapes. So 12 mode shapes, we can extract this. We can apply the different type of loads like pressure load, bolt pretension. We can consider the contact nonlinearity also. And now we can perform thermal structure analysis. So all that kind of analysis we can perform using this discovery tool. uh, from 25R1 we have some random vibration analysis capabilities also in the discovery tool, and some durability analysis capabilities also we are going to add in future, maybe in next version. So these are the basic capabilities. So if you talk about from workflow, so it is very easy. For example, I'm going to perform a simulation for a beam structure where the base plate is of some certain dimension. There is a base plate, and over it we have a I beam which is welded over it, and these base plates are welded through, bolted through. So I will just take you through how this workflow works. So for example, I'm going to model base plate. So simply I will select this.
Hello, Anil.
Yes. Please.
Yes, sorry for interrupt you. Thanks for first of all sharing the detail. I just wanted to know the limitation of discovery, like at that at what limit it can work. So we need to pass on the work to the higher module. You understood, right? What I'm trying to say?
Right. So for example, if we are dealing with some non-linear materials, so non-linearity we cannot consider here. Only
Okay.
frictional contact and sliding frictionless contact, that kind of contact nonlinearity, although we can consider. But in detailed analysis, if there are some different type of mechanism where the
Mhm.
highly nonlinearity there, or some material nonlinearity is there, that we cannot consider here in for static structural analysis. So the concept is that we cannot replicate mechanical ANSYS mechanical with the discovery, but initial
Mm.
level of simulation we can perform there in this tool.
Okay.
And yeah, so uh, from 3D modeling, there is no limitation. We can model anything in using this discovery tool. It is very best to do pre-processing type of activities as well. For example, if there is some already existing CAD model prepared in some other tool, so removing flats and everything we can do. Best thing for this tool is that no meshing is required. So basically, for example, we need not to deal to remove the flats to small features and everything, because it's works on meshless. Although we have some capabilities where we can control mesh size and all that thing also in the refine mode. So there also we have some capabilities where we can control even mesh size also. We can define the local mesh size, global mesh size. So that kind of capabilities are there in discovery tool itself. And if you talk about model analysis, so only up to 12 mode shapes we can extract in discovery. So there this is the limitation. And of course for dynamic analysis like harmonic analysis and all that, these capabilities are not there in this discovery tool.
Okay. Thank you. But just for a suggestion, better in a
Yes.
nutshell.
Yeah,
In a one
sure.
slide, you show the limitation in comparison with the advanced tool. So it will be very easy to decide, okay, I have to work
Right.
till.
Yeah, so basically already we have put some light on capabilities, and if you have some specific requirement, you can reach out us we will take your questions, no issue. That, for example, if you are dealing in some specific type of simulation, so we will clarify whether it is possible in discovery or not.
Okay, thank you, Neil. Please go ahead.
Okay. Yeah. So, for example, let's suppose I'm going to model for mounting boards. So simply, so generally, what features are there in any CAD tool? All these features are there. Some user interface might be different from other tools, but yes, we have all these features. So let's suppose this is my base plate. I can from scratch to surface, and then we can provide the thickness as well. Let's suppose it's 10 base plate. I'm just copy paste and considering one more. So the concept would be that we are going to bolt these two base plates, and the bottom one is fixed and the top one will be bolted to this bottom base plate, and over this base plate we have a I beam. So let's suppose it's 100 by 100. Let's suppose it's of 500 mm. Then we can define the thickness. Let's suppose it's of 7.5 mm. It's of 2.5, and yeah, this way also. So let's suppose this is my complete structure in that way. So you can see once you, for example, in bottom plate, I want to fix it. So once I will click on that, a halo will be there. I can expand it, and you can check the different modes like this. So we are in this model mode. So only the boundary conditions in the halo for the modeling purpose would be activated. Once we will go to this explore mode, here we can define the physics and structure as well. So for example, in physics, we are going with this structural steel. We have options to modify the material as well. So material library is already there. You can see we have a enriched library. So this inbuilt library is there where a lot of readily available material uh, properties are there. So this library will be by default with this discovery simulation tool would be there. So for example, if I have to fix this particular base plate, so I will simply go to this hollow. In mechanical, I can select these are the boundary conditions, different loading and boundary conditions. So for example, I'm going to fix it, so I can provide this fixed type of support. We can change it to the sliding displacement and all that, but as of now we are going to consider as a fixed support. So we will simply apply it over there. So you can see once we selected this support and we selected this physics structural analysis, so by default bonded contact between the different components will be considered automatically. So we can activate this gravity as well. For example, standard earth gravity we can activate. We can define the directions that we can do. And for example, if I'm going to apply some specific load at this particular location, so I will simply again click on that. I will go to the hollow, and from there I can define the load as well. Like as of now, I'm going to consider a force, and this force would be as per this component wise. So for example, in my I want to apply a load of some uh, 2000 Newton across this y direction, and in vertical direction I want to apply this load of minus 5000 Newton force. So that is how simply we can apply this force boundary conditions we can consider. And likewise we simply need to click on this solve button. So you can see it will we need not to work out much about the meshing, about different things. Everything will be automatically considered by the software. We just need to review, and we so here we can see the results. So if we talk about the deflection, we are getting the maximum deflection of 0.00016 meter. We can change the unit system, so it is very simple. So maximum deflection of this, we can animate it, we can check how the deformation would be there. You can see that would be the animation. Likewise we can check the different like one mesh stresses. What would be the one mesh stresses? So maximum stress of 23 MPa would be there. So that maximum stresses we can find out. We can find out the principal stresses, strains, reaction forces, contact stress, and all that things we can extract from this particular simulation. Likewise, for example, instead of this static structural analysis, I want to check the natural frequencies also. So simply I just need to duplicate it, and there we can define the so So for example, in this particular, I want to check the natural frequencies. I will simply click on that natural frequency, and here we can define the mode. So the limitation is that we can only extract maximum number of modes is the 12. By default, it will consider 3, but we can go maximum up to 12 only. So this is the limitation. For example, if I will select 6 modes, I simply need to check it. So you can see my first mode is of 278 MPa hertz. Second mode is 306, and we can animate it like this. So it is very user interface is very easy to adopt. Anyone can learn this tool just in 1 hour. That is how the natural frequencies we can find out. And for example, if I want to check what would be the impact if I change the thickness, so it will not take time. It real time simulation can be happen basically. So for example, if I want to just pull it, and I want to check what would be the impact if I increase this thickness by 2 mm, and the same way if I want to increase the thickness of the this side by 2 mm. So the simulation would be very real time. It will quickly perform the rerun the simulation. You can see this hello, this green is going on. Once it will stop, the complete analysis will be performed. So we can quickly uh, check. We can quickly alter the dimensions, and we can find out what would be the impact if we increase the thickness, what would be impact if we increase the number of bolting locations. So that kind of analysis we can do very easily. So you can see once we increase the thickness, that is the impact. The earlier mode, say 5 was 900 something hertz. Now it increased to the 1050 hertz. So this is one example. For example, now instead of this so here we can
Hello.
yeah,
Can I ask a
yes,
question?
please.
Yeah. So you just change the thickness manually. Is it possible to do some parameterization here? Let's say some range 2 to 5. Change the thickness.
Sorry, your voice is very low. Can you?
Can you can you hear me? Hello.
Yeah. You are audible.
Yeah. I meant to say, is it possible any parameterization there? Is there any tool or any kind of a ribbon there?
Yes. Parameterization is also feasible. We can do parameterization also in this.
Okay.
Yeah. So you can see here now it is combined actually. So I need to again split it for the bolting calculation also. Okay, so for example, this is my where I have applied a fixed support at bottom one, and now instead of this bonded contact, sorry, I will edit it. I will convert it to the frictional. So that kind of we can apply the frictional, or idealized will be frictionless. So for example, I'm considering a frictional coefficient of 0.2. So that sliding contact also we can consider here. And now, if we have to apply some bolting connection between these two, so either we can apply the joints as well. For example, once you will click on this hello in under the structure, we have the options for the different joints, like fixed joint or revolved joint and all that. Likewise, we can apply these bolt pretensions also. For example, this is the regarding bolt. So once we click on this, it will automatically consider the bolt size based on this hole. And likewise, for example, we want to apply the same type of bolt for the similar holes. So quickly we can do that kind of calculation, you can see. So we can assign this bolt to all these uh, holes. Right. So this is my bolting connection. Then we can apply the this directly we can go to, for example, if I click on that, so for example, I will simply click on all these. I will go to this hello. So there we have option for this bolt pretension load as well, this one. And in this discovery, actually we have option to apply the torque as well. Likewise, in mechanical, we don't have this option to apply the torque, but here we can apply the torque as well. But as of now, for example, if I apply some clamping force of 15,000 newtons, so simply I can apply this one. So software will first solve this bolt pretension load, and then it will apply the force. So that kind of calculation also we can perform. So so you can see this is regarding this. Uh, so without this discovery, what would be the stresses? That also we can check. So you can see here, due to this bolt pretension, the stresses and deflection would be shown. And four virtual bolts are automatically created in this model. Basically, you can visualize the stress levels due to this bolt pretension deflection. We can find out. For example, this is my one message stress levels. So at due to this bolt pretension, that is how the stresses will be there, like this. So we can perform that kind of calculation very quickly. And in refine mode, actually we can check the mesh size also, and we have the capabilities to just alter the mesh size to define the local mesh sizing. That capability is also there in this refine mode basically. So it might take some time. So this is the mass we have. The software has automatically performed based on geometric adaptivity in the refined mode. So in refined mode, we can change it the fidelity by selecting it to the higher bar, and also we can define the local and global mesh size also. So instead of this automatic sizing, we can apply some fixed parameters. Likewise, in local sizing also, we can define this some local hole size or that in this refined mode. So this is also possible. So likewise, we can apply the thermal loads also. We can perform static or transient thermal analysis in discovery tool, and then we can check what would be the impact of this thermal load to the structure analysis. So that kind of calculation also we can do in discovery for structural perspective. So any query, any question on that part? If you have, you can ask me, or you can drop your questions in chat box. So if there is no question, then I think we can pass to the Shubham.
Hello.
Then,
Hello.
yeah, yes.
Sir, can you just briefly give the information regarding when to use discovery and when to use space claim and when to use both of them?
So basically, space claim is not having this simulation capabilities. So basically, in Ansys, if you talk about discovery, there are three versions: Ansys Discovery, uh, Pro, Premium, and Enterprise. So if you talk about Ansys Pro, then this Ansys Pro is having only modeling capability. So there we can only do the modeling. CAD modeling is feasible. Or for example, you are already using some third-party tool like SolidWorks, Pro, Katia, whatever tool you are using. So designers do the include every detailed information in the CAD model. Like they will create small features like small holes, small fillets, everything they will include in the CAD data. But as a CAE engineer, being as a FE engineer, we have to remove some additional features which are not essentially important from a standpoint of view, or so basically that kind of geometric cleanup or geometric pre-processing we need to perform. For that we have this Ansys discovery or discovery space claim tool. So space claim and discovery both are very similar. We can say it is updated version of discovery. Discovery is the updated version of space claim. There we can model or from the scratch any CAD model, or we can do the geometric cleanup on the existing CAD model developed by some other third-party tool. Along with this modeling capabilities, there are further two updated versions or advanced versions of the discovery, like discovery premium and enterprise. There we have the simulation capabilities as well. So any designer who is working on design, he himself can perform some basic level or initial level of analysis, which is very accurate and very fast, and we can say very real time simulation he can do. He can evaluate his all the ideas, and he can choose one of his best, and that best idea he can final proceed for the further final analysis. So in that way, actually, the CAE engineers, most of work can be done at the designer himself, actually. So I hope uh, I answered your question.
Yeah, thank you.
Yeah. So we have one query from Mr. Rahman. Yeah, Mr. Rahman, please.
जी गुड आफ्टरनून.
Good afternoon. How are you?
हाँ हाँ ठीक हूँ. आप कैसे हैं?
बढ़िया. Yes, please.
हाँ, बोल रहे थे कि ये कौन सा इंटरफेस है. ये तो हम लोग के लिए नया है. हम तो एंसिस यूज करते हैं, तो ये इंटरफेस अलग से दिख रहा है. ये कौन सा वर्जन है?
सर ये टूल अलग है. मतलब आपके पास तो एंसिस स्पेस क्लेम है ना, जिसमें आप कैड मॉडलिंग करते हो, या फिर आप
हाँ स्पेस क्लेम भी है
वैसा
और
डिस्कवरी भी है आपके पास ना.
ओके.
हाँ
Okay.
उसी में एक डिस्कवरी भी आता है, उसी में भी वो कैड मॉडलिंग वाला टूल आपके पास है। अब उसमें कुछ
Okay.
एडवांस चीजें भी हैं जो आपके पास उसका लाइसेंस अलग से आता है, जिसमें
नहीं,
हम
मेरे पास तो
सिमुलेशन भी कर सकते हैं।
एंटरप्राइज लाइसेंस है। मेरे पास
वो
एंटरप्राइज लाइसेंस है।
मैकेनिकल का एंटरप्राइज लाइसेंस है सर आपके पास डिस्कवरी का भी एक अलग से लाइसेंस आता है, जो कि सिमुलेशन,
Okay.
बेसिक सिमुलेशन की कैपेबिलिटीज होती हैं उसमें,
Okay.
है ना। उसमें
Okay.
जैसे कंबाइन मल्टी फिजिक्स, वी कैन से कि उसमें एफईए भी हो सकता है अप टू सम एक्सटेंट, उसमें सीएफडी भी हो सकता है, और उसमें इलेक्ट्रोमैग्नेटिक्स भी हो सकता है। तीनों कैपेबिलिटीज आती
Okay.
हैं, बट वो जो हमारे स्पेशल टूल्स हैं, जैसे मैकेनिकल वर्क बेंच हो गया मैकेनिकल का, या फ्लुएंट हो गया सीएफडी के लिए, उस लेवल की
हम्म।
कैपेबिलिटीज ऑब्वियसली नहीं होती इसमें डिस्कवरी में, बट हम इनिशियल लेवल का एनालिसिस इसमें कर सकते हैं।
तो मेरा मैकेनिकल ये वाला एडवांस्ड है क्या, या
आपका
मैकेनिकल वाला ठीक है?
मैकेनिकल वाला इससे बेटर है सर, उसमें सब कुछ है मैकेनिकल वाले जो आपके पास है।
ओके सर, ठीक है, थैंक यू।
एनी अदर क्वेरी फ्रॉम एनीवन? Yes, local sizing for the design and cleaning of object space claim limitation. It looks a course must. Is it possible to? Yeah, we can provide local sizing in the around the whole, so that is feasible in discovery also. And but it will be possible only in refine mode actually. So for example, let's suppose I define this and I apply a value of. So now it will take some time to remesh it, but yes, of course, this mesh size would be about 2 mm at this particular curve. So for this, we have one more. Can we import for? Can anyone use it for prototyping? Is there free version for testing for primary use? So sir, you can reach out to our sales team. Definitely, they will guide on that part, that we whether we can provide you the free version or not. So you can reach out to our sales team. Definitely, we will help you out on that part. Can we import part from other CAD tool? Of course, we can import. So it supports so basically by default, .stp or IGS file format are supported by the Discovery, but yes, we can import native files of SolidWorks and all that. We can. So in mass, we don't have much explored, or we can say advanced features in this particular, like we have in mechanical. But yes, some extent we can do local mass sizing, and that is possible only. So basic idea for this discovery was not to do to replicate mechanical, or we can say, but initial level of analysis only we can perform that kind of. Where designer himself can do the simulation. So basically, anyone can adopt the software easily, and advanced level of expertise is not required to perform simulation in this tool. So generally, it is we generally can refer that it is meshless, but yes, in refine mode we have some features, but generally it is meshless software. So you can see we defined a mesh size of 2 mm at this curve. So now we have some refined elements over there.
Hello, sir, Milan this side.
Yeah, hi Milan.
Yes, sir, good afternoon.
Good afternoon, please.
Actually, I wanted to know that this software is capable to obtain the welding joint efficiencies or such kind of, if I want the efficiency of the welding joint. So this tool is helpful for that.
Sir, to perform detailed study, you have to go to the mechanical and workbench basically
Okay.
for the welding analysis. But yes, for strength of the welding, we can perform there also. In
Okay,
Discovery also we can perform strength of the WADs and all that calculation.
okay.
All right. So if there are no further questions, so we can move to the for next physics. That is Ansys discovery fluid structure. All right, then I will hand over to Subham. Subham, over to you.
Yeah, thank you, Anilji. so so we were discussing regarding, we'll start with the CFD part and then we will go to the demo also. So first we'll see what are the different capabilities available for the, or what are the different kind of simulations you can do with the CFD in Discovery basically. So as you have already gone through this, this is basically the design exploration, geometry preparation can be done, verification of design, and easy to use the UI. So this is basically the integrated geometry modeling where you can extract the fluid volume for internal flows, you can extract the fluid volume for external flows basically by creating an enclosure, import any CAD or neutral file formats, whether it's .stp, IGS or SolidWorks or CATIA, Creo, Proe. If every file support import support is available, you can create or edit geometry within the simulation workflow for the rapid change of designs, and you can rapidly convert the facets data to surface or solid. So this is a few of the examples for the integrated geometry modeling. Now moving towards what are the different kind of simulation CFD simulations which can be done using discovery model simulations. So basically for the fluid simulations you can do the internal flow, external flow. You can evaluate the flow rate, whether it's the pressure drop, the temperature of the fluid, and the fluid loads. You can do the steady state simulation as well as transient state simulation. Fluid thermal simulations can also be done. Uh, Basically this helps you with the instantaneous results. So once you start the simulation, instantly you will get to know the results, what are the results. You can easily extract the internal and the external flow geometry. Then there is another kind of simulation which can be done, that is the thermal management. So you can evaluate the temperature, heat transfer, thermal stresses of the components and the assemblies. This can also be done using the steady state analysis, or either you can go with the transient thermal simulation. You can link this with the high fidelity simulation for mechanical. You can club this with the workbench physics, and then you can transfer this with the mechanical tool for the detailed or the in-depth simulation. Then there is rotational fluid zone. So basically you can do the rotational kind of analysis, whether it's your agitator, whether it's your fan, whether it's your pump. So this kind of simulations can also be done with the rotating fluid zone. Basically MRF is the technique behind this. So you can perform this kind of rotational simulations as well. You can see how the velocities are behaving, how the flow is getting distributed. You can also do the parameterization. You can vary the different RPMs. So this kind of rotary simulations can also be done. Then there is a live GX solver in for CFD in a refined mode. So basically this helps you to uh, solve the fluids in the refined mode for the high fidelity simulation. So on the left hand side you can see you can specify the convergence, you can use the live GX solver. So basically when it comes to the live GX solver and the refined mode, you have the control more in the meshing side in CFD. For the CFD kind of simulations you can also do the polyhedra simulation meshing in discovery. So that is a new capability which is there. So also it basically requires 1 GB of CPU memory for 1 million of cell mesh count for basically. So these are few of the live GX examples. So the first one indicates how the fan cooled fuse box simulation is done for the conjugate heat transfer zone. How the fans airflow is circulating inside the entire box. The second one indicates the centrifugal pump, how the pump behavior is there, where are the rotational zones, recirculations, is there any recirculations or not, that can be identified. Then stability bleed system with the compressible flows can also be done. Then porous media simulation capability is also available. So you can also do the porous media simulations using Discovery simulation. These are few of the examples for the polyhedra meshing basically. So these are the few examples which we have seen. uh, Ideally before this version, the polyhedra mesh was only available for the fluent, which is for the in-depth physics simulation. But now this polyhedra meshing capability is also added to the Discovery simulations. So we can also do the we have the control of meshing in Discovery for the CFD part, that too all only in the refined mode. So we can perform with the poly mesh, the simulations can be done. We can also do the local refining. So if you see all these images, so here these are the locations which are locally refined, you can see. So these regions you can see where the mesh count is, the mesh element size is very pretty much small. So this can be done using the locally, and the BOI feature is also enabled now for the Discovery modeling simulation. So this is one of the examples, like I was talking about, we can change the geometry while the simulation is going on. So this is the classic example. For that we have increased the length, and you can see the simulation has not been stopped. We have just drag and dropped it over here. We have increased the length and the simulation goes on. You can see how the recirculation zone is forming over here. Ideally it was over here, and then we have stretched it up. If you do this kind of simulation for the in-depth simulation, or let's say you are working on the fluent or the mechanical part, so what you have to do, you have to go back to your Discovery or Space Claim or whatever CAD tool you are using. You have to increase the length, you have to mesh it again, then you have to give the boundary conditions again, and then you have to run the simulations for, let's say, about 500 or 1000 iterations, correct? But whereas in Discovery, if you are doing, you just have to drag and drop. You just have to drag and pull it up to the limit where you want to extend it, and then you can see you don't have to do anything. The solver automatically updates it, and the flow patterns can be will be updated within fraction of seconds. So this is one of the major advantages for the conceptual design stage. So if you are having a lot of prototypes, or let's say 5 or 6 different types of prototypes with minor changes are there, you can have a quickly simulate them. You can see what are the design impacts and what are the results of those impacts, and then you can take a call and you can go for the detailed simulation. So we also know, like as let's say you have done the basic simulation, now you want to do the detailed simulation for them, right? So basic level has been done. For in-depth simulation, you can transfer this to the flagships which are available. For mechanical, you can go to the mechanical module, and then for fluids or CFD part, you can go to the fluent or CFX part. So basically fluent is the ideally part, you can carry on with the fluent simulation for the in-depth simulation results. So easy transfer is available. So let's say this is the workbench window is there, we can link the Discovery, and we simply have to link it up. Otherwise you can from Discovery simulations also, there is an option for the workbench, mechanical and the fluent. So from here we can transfer it to the respected domain where we want to carry forward the simulation for the in-depth analysis. So now coming towards, there are certain latest features which are available in the latest module, that is 25R2, which is the recent release from the Ansys. So there are additionally few of the uh, features which are added up. So these are for basically from the meshing part. So body of influence is included in the CFD part. So you can now capture the body of influence, and you can also capture the sharp edges. So earlier there was certain limitations, like sharp edges were not getting captured correctly. If you see over the here, so the sharp edges he was we were not able to capture it properly, as we did not have much control. But now we have that meshing control in CFD part, so we can give the body of influence, we can sharp edges can be captured properly. So this is what the body of influence for any sort of external aerodynamic simulation. If you want to refine it, if you want to go with the high fidelity, or basically the more focused or accurate simulation, So what we have to do, we have to refine the mesh. We need to see how the weak regions are getting formed, how the flow separation is taking place. So flow separation can only be understood if we have a refined mesh. If we have a way too coarse mesh, that is a bit tough to study how the flow separation takes place. So for that, this local refinement body of influence is added. The bit basically it's added in the refined mode, and we can see how the refined mesh is available now. So earlier this was only available in the fluent side, the refinement of meshes and everything, but now this is added to discovery as well. So these are few of the examples for the local meshing. You can see over here how the local mesh can be done. The sharp edges, earlier there was a bit of challenge of capturing the sharp edges, but now if you see the proper calibration or capturing of the sharp edges is there. So for that there is a one option in the simulation options, so we have to enable that capture sharp edges, and the system solver will automatically capture it in a better way. So these are few of the examples for the same. So we can also do the internal fan simulations, or we can specify it on the cylindrical or rectangular fluid bodies. Automatic selections for the inlet faces and the user override is available. Fan for performance curve or the constant pressure rise can be plotted. You can plot the fan curve, basically fan performance curve, that is your pressure with respect to the volume flow rate, how it is varying. Also the fan libraries for the common electronic cooling fans has been involved in it, included in it, and yeah, you can use it with your avionics box or any of the electronic components. And you can also give the hub radius and the tip radius for it if you are going with the shorted ones. So that option is also available. So you can also perform a room HVAC kind of simulation, whether you want to, where the focus is only to see and analyze how the flow is going inside the duct and how the flow is getting distributed around the system. So for those kind of simulations, you can do the internal flow analysis. Then fully developed velocity profiles are also available. So this helps, let's say you are doing certain simulation and you are giving high uh, velocity or high mass flow rate. So initially it takes certain iterations or certain length to get the flow stabilized, but now uh, that is not required. A fully developed turbulent model, a fully developed turbulent flow and a laminar flow option is available, so you don't have to extend your domain. So from where you will give the inlet, it will consider it as a developed flow only. Also monitoring options are available. Individual monitorings like force is there, pressure is there, your temperature is there, can be plotted individually. If you see over here, this is for the individual value for the location given over here. So you also have in x, y and z directions, whichever directions you want to plot the forces, you can plot it. Heat flow monitors are also included for the explore mode. So earlier this was in the refine mode, but now this can be done using the explore mode. So explore mode is a very quick as compared to the refine mode. Refine mode, we refine the mesh, so that let's say if the refine mode is taking 3 minutes of time, explore mode will do it in 1 minute or so. So this kind of quick simulation and the heat flows plot is also available for the explore mode point. So now when we go with the latest 25R2 simulation, so earlier we did not have mesh control, correct? So now what we do, the system also gives us the mesh control. So we can come to know like what is our element size count, what is the phase count nodes, element sizes. So mesh statistics data can also be now seen with the refined mode or even with the explore mode. So these are the monitor details which you can save it and you can refer to it in your reports as well. So mass flow rate, details of mass flow outlet, average temperature, each and every report definitions are available, whether it's for pressure, whether it's for your mass flow rate, whether it's for your temperature, or whether it's for lift and drag coefficients. Lift force is there or drag force is there, that can be done. So this is these are the few of the more advanced options which is involved in this. So basically convergence stopping solution stopping criteria for convergence is also available. Now you can specify like at what values you want to stop the convergence. So earlier these functions were available in the fluent only, but now these are also included in the refined mode in the discovery simulation. So now we'll see one quick demo. So we'll perform an external aerodynamic simulation. So I have imported this step file from the models, and now I will move from here. So basically this is the entire UI of the discovery. So you already got an basic idea from as Anilji has already explained. So from model also you can extract the fluid volume. You can prepare in the prepare tab. Volume extraction option is there. So this is for the internal flow, this is for the external flow. You can create an enclosure, you can check for the interferences, you can review it, pre-check is there, share topology is there. If you are working with the mechanical part or the CFD part, you can perform the share topology over here. So basically this will help you if there are two overlapping phases. So if you give the share topology, that will consider as an interface and it will not act as an wall. So your flow, it will, the faces will allow the flow through it. So then we'll move to the explore mode and we can perform the simulation. But before moving to the explore mode, here are a few of the things, like let's say if you want to see the specific uh, lift or the pressure force over here, so what we can do is we can give a name selection. So let's say if there are wings or any wing is there, so what you have to do, you have to select this entire region, this is wing, and from here you can give the name selections from the bottom right hand side, create annex. So from here you can create a name selection. The shortcut is Control G, and we can give front. If you want to do any of the parameterization for that, this name selection is important. So now I have did the name selection, but if you see over here, this is the entire name selection for the body, but I want to do the name selection for the surfaces. So what I have to do, I have to select it manually. So you can double click on it, you can select the entire face. In similar way, you can double click on it, then double click here. So once you go with the double click, it will select the entire loop. And now if you give the name selection, you can see this is the planes. So now what I will do, I will move to the explore mode. In explore mode in CFD, you also get the fidelity to increase and reduce the fidelity option. So let's first see what are the different options available over here. So when you see on the top ribbon, we have the materials tab is there, internal flow, external flow is there, then fluid flow is there, and solid thermal flow is there, which is relevant to your CFD part. So now what we have to do, first we have to create an outer domain basically. So how we will create it, there are two different ways. Either you can go with the volume extraction, you can create an enclosure and then you can do certain operations, subtract operations, and then you can define inlet and outlet. Then other is quickly, what you can do is you can go to the external flow. So these are the external flow cavities, basically boundaries that we have to select from where the fluid is going to enter, basically inlet and the outlet region. So I will select this as an inlet. So once you select this as an inlet, it will by default extend the domain at the back to see the wake regions. And now we have to select the ground plane, so which is the grounding plane. So we have to select this particular region, and once we do it, we can see the entire enclosure has been formed. On left hand side you can see, so flow inlet is there and flow outlet is there. So by default it has created flow inlet and flow outlet. So now what we can do is, let's say I want to, my vehicle is moving with 30 miles per hour. So I will go over here, I'll change the unit miles per hour and I'll give it over here 30 miles. It will by default convert the miles per hour to the meters per second, and the flow outlet is the pressure outlet only. And now simply what we can do, we can go with the simulation. So now if you see, the solve button has been enabled. Earlier this was disabled, but as soon as we have given the external flow conditions, the solver button has been enabled. Now what else we can do is, so this is one of the way we can simply do it. Other thing is we can create certain monitors. So basically I want to observe like what are the drag force which is acting on my front wing or rear wing. So how I can do that? So what we can do is this is your heads up display. Once you enable this, your monitors option is there. We can go to the monitor options, we can select the variable. So what you want to see, velocity, static pressure, each and every option is available. So right now I am concerned with the force, so I'll select the force. I'll hide this, right click and hide this enclosure, and I'll select this front wing. Or let's say I want to see the drag on the entire vehicle. So what I can do is I have selected the force, I'll select this entire box, select it, and which direction you want to see. So x will be your lift, x is not relevant, z will be your lifting force, y is the drag force. So I'll select the drag direction over here and I'll simply give OK. So you see one dot is created that indicates one y force monitor has been created with respect to force. So I'll simply double escape it and I will showcase show all. So my enclosure will come into the picture, and now simply I can start with the solution. So once you start with the solution, you can see this white line is going around this. So once it's completed, this line will get stable, the white one. So by default, if you see, the maximum velocity and the pressure drop plot has been generated over here. So these are the few by default plot which are available. So I'll turn off the contours. Let's see, I want to see you got the force value of 106 newtons. The entire drag force on the entire car is 106 newtons. In similar way, pressure drop value you can see from inlet to outlet. What is the pressure drop value and what is the maximum velocity? So maximum velocity you can see 16.6 meter is achieved. Now we can do certain post processing. Let's see, you want to see the velocity vectors, you can plot the velocity vectors. Here are the tail length, and here are the few certain thickness. You can reduce the tail length, you can increase the count based upon the requirement or how you want to analyze this. So vectors you can plot, particles also you can track how the particles are flowing. So one by one we'll see. Let's say I want to do the streamlines. So for streamline, let's say I'll orient this in the center part. So you can see you can increase or decrease the thickness of the count, and you can see how the flow is getting separated. In similar way, you can see particle tracks. In similar way, this is for the velocities. You want to see the contour. So these are few of the post processing. This is for the ISO surface, how the wake regions are going to form. In similar way, you can plot the vectors. You can go on the top view and see. So this is basically, here are certain zones where the recirculations is taking place. If you see this blue vector, this is the vector. These are the certain vectors where the flow circulation is taking place. So this kind of post processing can also be done. If you see the side view, you can see the flow disturbance and the turbulence regions over here, wake regions. So this can be better captured with the streamlines, and here if you see there are no flows. So this is the flow separated regions which is there. In similar way, you can check the pressure and the force values. So this is one of the ways how do we perform any quick simulation for any sort of external aerodynamic simulation. So here also you can do the parameterization for different parameter values for different let's say inlet flow conditions or outlet conditions. So just beside this there is an option for the parameter. So you can add or remove parameter. So if I select over here add parameter, add as parameter. So as soon as you add this as a parameter, you can see over here your parameter is there. So once you enable this, this is the design value one. So you can add the variation from here. Variation as many as you want, you can add it from here, and you can also solve this, update this for the current as well as for how many you have added it, and all the monitor plots which you have plotted over here will come over here. So let's I'll do not 30 miles, I'll do this as a 15 miles. I'll select this one also, and I'll select uh, once you update you will get an option for update selected, update current and update all. So I'll do update selected, and you can see the simulation has been started. So in this way you can also do the different parameterization. So this is one of the examples for the controlling the flow rate parameterization. In similar way you can also do the geometric parameterization as well. So where you can vary the angle of attack differently. So here if you see the maximum velocity is 8.49 meters per second, pressure drop is 3 e to the 3 pascals and 26.7 newtons. Now what I want to do, I want to update it all. You can simply do update all. So the simulation will run quickly and you can see what are the different parameters. So this is one of the flow parameters which you can do. In similar way you can also do the geometrical parameters that we have to create uh, in the modeling part. So here you will be getting a comparison how different the values are getting. So right now as I have selected update all, the second iteration is also going on for the design value point of 6.71 meters per second. So once this is update you can take capture the values from here, or you can also export this as a CSV file. So these are the different options which are available. So now we'll quickly do one internal flow analysis. So this one example is for the valve. So I don't want to save it. So this is one of the examples for the valve flow. Fluid is basically you can we can also change the fluid from here. The basic or the by default solid material is structural steel. By default material fluid material is water. You can double click on it and you can change the material from here. If you want to do with air, ammonia, any of the materials, or you can also create your own material from here. From here you can change the velocity sorry, the values and properties, and you can create your own material as well. The solid will be by default structural steel, so for that also you will get the structural steel values is there. If you want to enable the gravity or initial temperature, we can give initial temperature, the flow rate at inlet, and the outlet is the pressure outlet basically. And let's say I'll start this simulation. So I have started this simulation, and meanwhile it came in my mind I want to drag this, I want to extend this domain. So what I will do, I will simply select this face, I will go to the heads up unit. From here I will go to the modeling options basically, and I will simply pull it up. So as soon as I pull this diameter and the length, the simulation is continued. Within fractions of second, you can see the simulation is started again, and it's continuing from there. So this is how you can utilize the quick edit options at the basic or the preliminary level, where you are not sure with the designs, or let's say you have a lot of 4 or 5 different prototypes and you want to see which is efficient. Instead of prototyping it, manufacturing it, and testing the prototype in physical, you can work on this physical testings, and you can replicate those scenarios in discovery for the quick and efficient simulation. And on the left hand side, right hand side, there is a legend. You can see the minimum and the maximum values of the contours. So basically velocity is there. So let's say if I am pointing my cursor over here, so if you see on the right hand side in the legend, so that horizontal line is indicating it's from so whatever the maximum value is, so it will be replicating on the right hand side. So if I am taking this over here, so the value of velocity is 0.312. If I am taking it in the narrow section, so where the velocity is increased, so you can see the velocity is somewhere around 2.2. So this is how you can validate it and compare it with the numbers, numerical data basically. You can also change the units as per the requirement. Instead of velocity, if you want to see the pressure, you can also plot the pressure, and in same way you can also see the pressure values as well. You just have to move your cursor over there, the region where you want to see the values, and in those regions you can see the values basically.